This is Elm and React in production. I'm Richard Feldman. So this right here is the Apollo Bridge right here in Bratislava. It's about 10 years old, which in bridge years is not very many. Right? It's a relatively young bridge. But in software years, that's a lot. Right? A 10-year-old application, you're still maintaining that same thing. That's a pretty long time. And I think the reason for the difference there has to do with the fact that software, things tend to change a lot more, right? Projects get canceled, they get redesigned, they get rewritten. In fact, if you got a 10-year-old project, probably you're getting people asking you, why have you not rewritten it in the latest and greatest thing yet? But sometimes, every once in a while, something unusual happens. Project succeeds. Now, we have to maintain it. How many people have had this experience? You've ended up maintaining a software project way longer than you anticipated when you set out to start working on it. Yeah, me too. It's a pretty common experience, I think. And when you do this, you end up asking yourself this question when things sort of go unexpectedly. Why did that happen? What happened there? There's a bug, there's some sort of unexpected behavior going on. And ideally, as you've been growing the project, you've been doing a good job keeping things simple and maintainable, right? You've been doing a good job keeping things organized, and you can sort of trace back and figure out why that unexpected thing happened and fix it. But all too often, we end up with something slightly different, right? We've all been there. But nobody wants to get there, right? Nobody sets out at the beginning of a software project thinking, you know, someday this project will succeed and I will maintain it as a gigantic mess. No one thinks that, right? What we all want to end up with is if the project succeeds, it ends up nice and maintainable. So how does this happen? How do we end up in this unintended place? Well, for my money, it has to do with the individual decisions we make along the way. We don't know if the project's going to succeed. We're just kind of taking it one step at a time, and we sort of tend to reach for the most convenient thing. We got this cable in our hand. We got to plug it in somewhere. We're like, I'll just do the most convenient one, which is right there. And then you say, which is the most convenient? Oh, that one's next most. And sure enough, sooner or later, you end up with a big mess, even though each of your individual decisions along the way were just pretty harmless. You're just doing the convenient thing. So I think that taking the convenience route each step of the way ends up with a big mess, unintendedly. And I think you have to sort of insist on simplicity each step of the way if you want to end up with a nice, maintainable project if it succeeds and you end up finding yourself in a position to maintain it. So this is what appealed to me about React when I first found out about it back in 2013. This idea of simplicity, and in particular, the simplicity of the render function. It's this really simple yet powerful idea of passing some state to a function and just having it return a description of how you want the DOM to look, as opposed to doing all this wiring within the DOM, talking back and forth between things, two-way data binding. Much simpler to just say, here is the state, and then here is how I want the DOM to look. I was not the only one back in 2013 who thought this was a good idea, but we were definitely in the minority. In fact, we were in such a small minority that after React was announced, it got so much blowback from the community that Pete Hunt went on this speaking tour called Rethinking Best Practices. And rethinking best practices was not originally intended to be a compliment. As he describes in the talk, this was actually based on a tweet of someone criticizing Facebook saying, oh, Facebook, rethinking best practices, throwing everything out the window. Which, you know, to be fair, I mean, this was pretty far afield right when it came out. If you look at that slide in the background, it says Meet React, aka the V in MVC. MVC short for Model View Controller. So some of you may remember that this used to be the dominant paradigm. I mean, the absolute best practice back in 2013. This is what everybody was doing. But React was not. React said, you know what, don't care what everybody else is doing. We think we found something better. And Pete did a really good job articulating this, I think. He said, we've found that there are certain best practices that deserve to be challenged. Really resonated with me. I think this is true, and I think this is especially true in the service of simplicity, of trying to find a simpler way to do the same thing we've been doing. So I work for a company called NoRedInk. We make grammar and writing software for English teachers, and back in 2013, we first decided that we were going to give React a try. The way that we did that was just by saying, let's ship something small. Just get one small thing and take it all the way into production. We just picked one page, put one small part of one page, and said, we're just going to take this one feature, implement it in React on this one page, and get that all the way into production. Not a whole rewrite, just saying, yeah, just that one thing all the way into production. And the production part, I think, is really important. Because when you're building toy apps, there are all these things that you can just sort of forget about. But they're important questions to be asking yourself. Things like, how are we going to build this? How are we going to test it? How are we going to deploy it? How is it going to fit into our process of creating software and getting it to our users? And without asking these questions, there's just sort of always this invisible barrier between you and the idea of using this new technology in production. But once you've actually gotten a small thing into production, like we did, then these questions go away. They've already been answered. And from there, you can take this small little bit of React you've got in production and expand it and say, oh, well, now it's not such a big deal to say, we want to do this on our next feature. Just do a little bit more, and a little bit more. Until eventually, after about a year, we went from having just introduced React a little bit to it becoming the dominant paradigm of our front end in 2014. And it was all just from that little seed we planted back in 2013. And things definitely got simpler when we started using React. Our code got nicer, things were easier to maintain, life was just better. But sometimes, as much as you try to aim for simplicity, you get complexity just sort of creeping in from business requirements, right? This is not to do with the technology choices we've made. This is just complexity that comes from the fact that we're building something that needs to be complex. So as an example of this is our assignment form. So this is back in 2014, this was how it looked. This is all in React. So we have a tabs component up here across the top, got assignment names, some questions, you can scramble the question order, points, got potentially many different classes here. We got a component for selecting specific students within a class to give the assignment to. Got a due date, you can have some options here. Then we've got this big accordion component down here that's got all sorts of different options you can select with different topics to select and all sorts of different variations. Just a lot of stuff going on here. But the stuff that's going on here is not complex because we've done a poor job implementing it. It's just complex because the business requirements are complex. So, in order to maximize maintainability, we've found that there are just sort of certain things that you can follow that lead to things maintaining as much simplicity and as much maintainability as possible as the code base grows. And these are some things that you've probably been hearing throughout the community. These probably won't come as too much of a surprise. Instead of using mutable objects for a lot of things, just prefer immutable data. There's just sort of less to worry about when you're just handing data from function to function and you're not able to mutate it or not worry about that the function that you're giving it to is going to mess with it. Creates a sort of smaller web of dependencies. Also avoiding stateful components in favor of stateless components. Going back to that idea of the render function itself being incredibly simple, a stateless component just boils it down to that function. It doesn't have this sort of coupling or the co-locating of state along with the UI logic. And finally, avoiding imperative side effects and instead preferring declarative pure functions. Like we've heard that you should always use pure functions in your render function, you should always use them in reducers. Really just in general, the more pure functions you can do, the simpler your application is going to be, the easier it's going to be to maintain. Then, of course, with these best practices, these ideas that will sort of make life easier, you got to ask the question, how easy is it to stick to this? Because we're human, right? I mean, nobody wants to end up with a code base that's difficult to maintain, and yet we very frequently do. And the reason for that is that when one of these is sort of right at hand, it's the most convenient thing. You say, yes, I know I want to be mostly immutable, but just this once, I'm going to mutate something and then move on. I'm on a tight deadline. And then, one thing leads to another, and eventually, that one decision ends up biting you later. There's this really interesting question of, can we do better than just sort of telling ourselves not to do this, than using discipline to avoid using these things that are in our toolbox and just say, well, let's just pretend that they aren't. Like, what if we just didn't have imperative side effects? What if we didn't have stateful components? What if we didn't have mutable objects? What if our toolbox was just the simple things, mutable data, stateless components, and declarative pure functions, and that was all we had to work with? If that toolbox sounds appealing, you might understand why we might be interested in Elm, because this is exactly the toolbox you have in Elm. It's just immutable data, pure functions, rendering things. That's it. So Elm is a functional programming language, if you haven't heard of it. It compiles to JavaScript, and it has a very overt focus on simplicity, to the point where Elm does not have a component system at all. If you search through the guide and look for the word component, the only place you'll find it is explaining, by the way, you might be used to a component system, here's why we don't have one, and here's how you do things instead. No component system at all. You might be saying, wait a minute, like, how can you just have functions all the way and no components? Like, that's bizarre. That's not how anyone does it. Like, if you throw a rock, you will hit a JavaScript framework that has a component system. It's everywhere, right? And to that, I would like to refer back to our good friend Pete Hunt and say, you know what? I think that there are certain best practices that deserve to be challenged. And in particular, they deserve to be challenged in the name of simplicity. So, how did this go, this switching to Elm, just trying it out and implementing something? Well, let's take a look. This is our assignment form from 2014. This is our assignment form today. This is what we have in production right now. It's grown over the years because, again, the business requirements have changed. We've tried to make it seem a little bit less intimidating by sort of using this progressive reveal, but there's actually quite a lot to be revealed, right? So we have a bunch of different students here. There's some form validation going on as I check and uncheck things, a bunch of different types of practices and quizzes and things that we can give to users. If I click this button, bam, this pops out. We've got a whole bunch of topics you can select. You can see we've got these accordions right here like before. As I check these, it's going to actually be syncing with the UI in the background. There's just a whole lot of stuff going on here. Okay, so this is more complex. It's sort of unavoidably more complex due to the business requirements having gotten more complex. But what if I told you that between comparing this assignment form to this much simpler one in terms of business requirements, this one implemented in React, this one implemented in Elm, that of the two, this one's easier to maintain. We actually used to be afraid of maintaining this. Like every time we'd release some new content, it'd be like, somebody's got to go mess with the assignment form. No dibs, no, not me. I mean, it was really tough to maintain it. But this Elm-based one, this is not something people are afraid of. Anyone feels free to maintain it, even if they just join the team. We have no compunction about saying any new team member can go in and edit this thing. Because Elm has this intentional focus on simplicity, and of course, I would be remiss if I didn't mention it also has a fantastic compiler that's incredibly helpful. I'll talk a little bit more about that later. So, how did it go? Went incredibly well. We now have 50,000 lines of Elm code in production. We've been using it more and more. We planted that small seed and just kept growing it and growing it. We've now been using it for over 1.5 years in production, and something that you may have heard me say before, we've got this error logging service that tells us every time we get a runtime exception. So we've been getting runtime exceptions for a very long time. We've been, ever since I joined the company, React, JavaScript, anything in there has been throwing lots of runtime exceptions, and we log them every time we get one in production. Our Elm code, these 50,000 lines that we've been using for 1.5 years, the total number of runtime exceptions we've gotten from our Elm code in that entire period of time is 0. That might sound like a preposterous claim if you've never heard me make it before, but I've been making it over a year now because it still hasn't happened yet. We're still waiting for the first case where we actually find our Elm code crashing something in production. This does not say it's impossible, right? I mean, obviously, you can just write something that recurses indefinitely, you can blow the stack. I mean, there's plenty of ways you can get an Elm program to crash, but the point is, it's surprisingly difficult to do it by accident, right? I mean, if you actually care about what you're deploying, the compiler just does such a good job of finding these things ahead of time that it just hasn't happened to us yet. So in addition to making our code more maintainable through its simplicity, through the compiler, it's also made our code more reliable. We're able to deliver a better experience to our end users because of this. We did this exactly the same way as we did with React. We just started by saying, hey, let's ship something small, just one small part of one page, and get it all the way into production. Get all those questions answered. How are we going to build it? How are we going to test it? All of that. Once you've got something small in production, a lot of unknowns go away. So, 2013, we started off with a little bit of React. 2014, React sort of took over our front end. In 2015, we introduced just a little bit of Elm to that mix. So at this point, we now have React and Elm coexisting. So let's talk about that for a little bit. So you can sort of add a dash of Elm to any given page. We talked about that earlier. Here's one of the examples of that. So we've got here our home page, and almost everything you see here is just plain old static HTML and CSS. One exception, the login button here. So this is Elm code right here. This thing that just popped out, this is all just done in Elm. So I can try this, it's going to validate, it's going to give me a network error because I turned off the Wi-Fi. But all of this stuff is just a tiny little embedded Elm application right there in that one little div. That's all it takes. If you're thinking about getting Elm into production, do it like this. Just pick something really small, something really low risk, where if you try it out and you decide you don't like it, you can just say, okay, well, we'll just rewrite it in what we were using before, no problem. That's all it takes. If you're wondering in particular how to do this with React, there's this great blog post called How to Use Elm at Work, and it's titled that because this is sort of the most common way that we hear of people successfully starting to use Elm at work is introducing it incrementally like this. And it's at elmlang.org/blog. Just scroll down a little bit, there's that blog post. And the way that it explains to do this is it gives the example of how to embed an Elm application inside a React component. That's all it takes, just adding a little dash of Elm. You can also go the other way around and add a dash of JavaScript to an existing Elm page. So this would be some case where you need to leverage the much larger JavaScript ecosystem or the React ecosystem. So one amusing example of this is, talked about this 2014 assignment form built in React. We didn't build the whole thing in React. This little date time picker right here, this is actually jQuery because we couldn't find something that had both the date and the time that had like the UX that we wanted anywhere except for this jQuery date picker. Fortunately, React lets you interop with arbitrary JavaScript stuff, and so we were able to do that. Turns out, Elm also lets you do that. And this whole page is not actually in Elm because we still have that same jQuery date time picker in the assignment form that we're using today. We still have not found a better one that we like better. So you have that escape hatch in React, and you also have it in Elm. So Elm lets you do JavaScript interop, and as we like to say, any page that's 99% Elm and 1% JavaScript, totally happy to maintain that, because whenever anything crashes, you know exactly where to look. So hiring is a good question. It's a question that I get asked a lot. Actually, earlier on at the conference, somebody came up to me and said, "Hey, so I heard you guys use Elm in production a lot, but how do you hire people? Like, how do you hire Elm developers?" And the answer is, first of all, that we don't require any Elm knowledge coming in. We just, if you don't know it, we just teach you. But as to the question of, how do you find people? So this is a visualization of our hiring pipeline before we started using Elm and telling people about it. And since we started using Elm and telling people that we use Elm in production, it's gone from this to this. We have gotten flooded with applications. I mean, seriously. Like, I have to tell you this story. So I was practicing this talk for one of my coworkers, and I had like a much more toned down version of this visualization. He was like, no, that's not enough. They're not going to get it. Like, Three Gorges Dam, that's the only like appropriate metaphor for what's happened. I mean, seriously, like, good programmers want to use awesome technology, right? That kind of makes sense. Elm is awesome technology. I can't remember the last time I did an interview where the candidate didn't bring up wanting to use Elm as the reason they applied. Like, it's just incredible what it's done for our hiring process. It's almost impossible to overstate. So the idea of how do you manage to hire people? I'm like, I don't remember how we managed to hire anyone before Elm because it was incredibly difficult, and now it's much easier. This might be a good time to mention, by the way, we're hiring. We do hire remote people. You don't have to know Elm on day one, totally not a problem. And we hired several people in Europe, so remote from Europe is totally cool. So onboarding is something you might be wondering about, since I'm saying that we're onboarding people to Elm if they don't already know Elm. I actually am able to compare our onboarding experience from React and Elm because as early adopters of React back in 2013, we're also familiar with what it's like to try and get someone from zero React knowledge to learning React, in addition to getting from zero Elm knowledge and to being able to contribute on the Elm side. Granted, like this day and age, obviously more new hires already know React than Elm. That's just sort of a given. Something that might be surprising, though, is the amount of time that it takes someone to get productive if they don't know either of them, pretty much the same between the two. And that might sound like strange, in particular because Elm's a totally different language. Like React, you still write JavaScript, so if you already know JavaScript, you already have a huge leg up. Elm, different language, obviously more to learn, so how could it be that someone going from zero knowledge in that particular area to being able to be a production contributor is about the same for React and Elm? And the answer is just that Elm's compiler aids beginner learning a lot. So let me give you an example of this. Let's say I wrote this Elm code, if string.length user.lastname then. So this is calling the string.length function on user.lastname to get back the length of that string. And this is actually going to be an error. Let's take a look at what the compiler tells us. It says, type mismatch. This condition does not evaluate to a Boolean value, true or false. It's got a little red squiggly underline under the offending condition. It's got the line number on the side there. You've given me a condition with this type, int, but I need it to be bool, hint. Elm does not have truthiness, such that instance strings and lists are automatically converted to Booleans. Do that conversion explicitly. So not only does it tell you about the problem and where it is and give you about as much detail as you could want on it, but it even has hints for common beginner mistakes like this. right? So it's sort of a built-in teaching aid into the language. Obviously, we don't just turn people loose and say, just go bang your head against some compiler errors and then you'll know Elm. That would be a little unrealistic, but it definitely helps. Give you one more example. Let's say I wrote this code. This would be totally valid JavaScript code, first name plus space plus last name, but it's not valid Elm code. I'm not going to tell you why. I'm just going to show you the error message. Let's see if you can learn it. Type mismatch. The left argument of plus is causing a type mismatch. Plus is expecting the left argument to be a number, but the left argument is a string. Hint, to append strings in Elm, you need to use the plus plus operator, not plus. Well, you all just learned something from Elm, and I didn't even have to teach it to you. I just read out loud what the compiler would have told you. So, this is why our onboarding experience with Elm is able to be about comparable to the onboarding experience we had getting people to learn React from scratch, even though it's a totally different language. This compiler is just unbelievably helpful. By the way, if you're wondering whether having this level of compiler support makes our lives easier from a maintainability perspective, oh man, yes. It is unbelievably nice. I really never want to go back. From the technical debt perspective, this has some implications. So there's this sort of saying, if it compiles, it usually just works. And this is something that people have had this sort of shared experience around in Elm. If your code compiles, usually it just works. Now, that's nice when you're building new stuff, but it's incredibly nice when you're refactoring. It means that we end up refactoring way more often than we used to, way more commits that are looking like this. This is an Elm refactor that we had recently. And the reason that it's so much easier to refactor is just that when you refactor our React code, we used to have this experience where we would change a bunch of stuff, and then a bunch of stuff would break, and also a bunch of our tests would break. We'd have to go rewrite the test, and then hopefully we're covering as much as we were before, but maybe not. And then we'd get it into production, and maybe we would crash. We would have some bug that cropped up, some regression, and we'd be like, no, I mean, the refactor, yeah, the code is nicer, but it's a bummer that we introduced that regression. But with Elm code, we just don't really have that happen very often. Like when you change stuff in Elm code, no matter how big the code base is, no matter how many files it's spanning, the compiler looks at all of them. Regardless of whether or not you have tests covering those things, the compiler is going to tell you if you hooked things up wrong. If they no longer fit together, it's going to let you know. Which means that if you have this experience of it compiles, it usually just works, you feel this incredible freedom to refactor. It's no longer a scary proposition. It's something you can just do and just be like, oh yeah, that'll probably just work out again. So you know this story. One of my coworkers who works on the ops team, he knows a little bit of Elm, but like just enough to be dangerous, as it were. He told me that he actually feels comfortable making pull requests against our Elm code base to introduce refactors when he comes across things that he thinks could be a little bit cleaner, because even though he doesn't know Elm very well, the compiler's got his back, right? I mean, he's confident that if it compiles, he's not going to introduce a regression, even though, unlike the rest of us, he's not working on Elm every day. This also impacts new features. So it is definitely the case that if I'm building a new feature from scratch, like React will get me something on the screen that works, that I can try out in less time. And the reason for that is stateful components, right? So if I want to have a date picker and I want to introduce that to my application, in React I can have a stateful component date picker, and I can just drop it in one place and it's just going to work. That's it. That's the end of the story. But because Elm doesn't have that, I now have to actually say, okay, over here I want to introduce that to the rendering part of my app, and over here I want to introduce the state management that goes with that. It's sort of two different steps instead of the one step where you just drop it in and it just works. So that means that it's less time to get something rendering in React than it would be in Elm. But what we found is that it takes less time to go from 0 to shipping the feature in Elm. And the reason for that is that although maintainability has a lot to do with fixing bugs and making your code cleaner and finding edge cases and stuff like that, you still do some of that on the way to the first time you're getting something into production. Like, the first time you get something up on the screen, you're like, great, this is pretty good, but that's not necessarily what you're going to get when you take it through a full QA pass, when you try and really push its limits and find out where things are going to break. Because Elm gives us this additional layer of help from the compiler, as we're going from start to finish, we end up getting so much help that it more than compensates for the amount of additional time it takes us to set things up because we don't have stateful components. So it's a net cost savings if you consider the time from 0 to getting something into production, which for our money is the metric that we care the most about. Community, okay, so the React community is huge. The Elm community is much smaller. But I do remember a time when the React community was small, right? When we first got into React, people were saying the same things about the React community that we were about Elm. They say, well, how can you abandon this huge ecosystem of MVC stuff? Like, how can you, blaze this new trail? And we said, well, we think it's worth it. We think it's a nicer system. And the community grew over time, and now the React community is huge. The Elm community, much smaller, but it is growing pretty quickly. This is, Matt did this visualization of Elm GitHub repos created by month. So yeah, there's a lot of momentum to this thing. Still not big, still not as big as React, but growing pretty quickly. There's a ton of meetups happening. They like to do little variations on the Elm logo, which are pretty sweet. I'm a fan of quite a few of these. And we also recently had the first ever Elm conference co-located with Strangeloop. So yeah, small community, but definitely growing quickly. And there were about 230 people at ElmConf, and it was exciting to just see everyone coming together and just sort of being a part of this growing thing. So, all things considered, we started off with just introducing a little bit of React, and then we sort of grew that and expanded it, and had it going from being in production to being the dominant paradigm of our front end. And we introduced a little bit of Elm the year later. And then now, we've actually gotten all the way to the point that Elm has become the dominant paradigm in our front end. And actually, most of our front end code is now in Elm, and React has become legacy code for us. So, would we do it all again? Would we go through all of that stuff, just introducing things incrementally, growing it and growing it? Yeah, absolutely. It's been a fantastic experience. So, if you want to learn more, a couple of resources to recommend. Elm Weekly is just sort of a weekly mailer, just tells you what's been going on in the Elm community. Elm Town podcast just started up. It's a podcast dedicated to Elm. There's a guide for getting started, guide.elmlang.org. Check that out. Slack. Amazing Slack channel, like lots of help, especially in the beginners channel. Super friendly people. Shameless plug, I have to mention, I'm writing a book, Elm in Action for Manning Publications, available for early access. I believe they have a discount code for this conference, so please check that out. So, if you're considering Elm, if you're thinking about it, sounds interesting, but I haven't quite gotten the ability to get it going yet. What I would suggest is ship something small and get it all the way into production, and then you can see whether you like it or not. Thanks very much.
Thank you, Richard. Awesome. So let's go through the questions. It seems we have quite a few of them. So let's see how many we can fit into 5 minutes. How can you optimize immutable data structures to be performant in low CPU environments like mobile phones or IoT?
That's a good question. That's a good question for somebody who's a compiler author, which I totally am not. I don't know how to optimize those. What I can say is, if you look on the Elm website, there's a blog post called Blazing Fast HTML Round 2, and it's got benchmarks of Elm against like React, Ember, Angular, a bunch of popular frameworks, and Elm is outperforming all of them in render performance, on top of which, in that benchmark, Elm was severely handicapped because it's doing lots of performance optimizations that Evan thought would be cheating to show in there. So basically, TLDR, Elm is quite fast. I'm sure you can probably do even better than that if you're optimizing stuff for low CPU environments. But if you think that things like React, Ember, Angular are fast enough for your purposes, then good news, Elm's going to be even faster.
Should I learn Elm or Reason?
Elm.
That was fast. I'm going to continue with why.
To be perfectly honest, I don't know Reason. I really can't speak to that. Had I used both of them, then I could probably say something intelligent about it. But I've used Elm. I'm extremely happy with it. I'm sort of aware of the characteristics of Reason, and it doesn't seem like it has anything to offer me. Maybe if I wanted to use it on the server side, because Elm does not have server side yet, and probably won't for quite a while. So if I wanted to have the same language on the client and on the server, that would be something that would appeal to me about it. But as far as the front-end language goes, I mean, I don't know, doesn't really seem like I have anything to gain from switching to it. So
continuing at the question, what's the worst part of Elm for you?
Yeah, so that ties right into it. The fact that I can't use it on the server. So, I mean, I say that in jest, I would really love to use Elm on the server, and I'm excited for the day that I can. But that does mean that, so I used to have an application where I was writing Node on the server and JS in the browser. And so, just having the same language in both places was pretty nice. And if you choose Elm, you just can't have that. So I guess I would throw in one other, extra worst part about Elm. I mean, like that's the thing that I like the least. But the other thing that is sort of like the hardest part is just like the learning curve, right? So it's a different language, and that means that like if I'm trying to get somebody to like work at NoRedInk or talk about Elm with me, if they don't already know it, then I sort of have like a significant bridge to cross before I can like have intelligent conversations with them. And I'm still sort of like struggling to figure out how to communicate more effectively when we don't necessarily have all the same shared jargon.
What about dead code elimination and code splitting in Elm?
So that is sort of going to be the focus of the next release of Elm. So there's 0.18 is about to drop in like probably less than a month. The release after that is looking into all that stuff. So right now we basically just like use Webpack and just sort of like do Webpack related stuff. And like there's no Elm specific like dead code elimination or code splitting, but it seems like there's a big opportunity to get into those things, and so it's sort of like under active investigation, but TLDR is not a thing yet, like in pure Elm, and so if you require those things, then honestly, I wouldn't recommend using Elm yet, but I would definitely keep an eye out for that release because I expect that, based on past releases, that it'll be nice when it does exist.
What about when is Elm 0.18 going to be released? How many more iterations until version 1.0 gets launched?
So 18, I'm guessing, is going to be released in probably the next couple weeks, so less than a month. I don't know for sure because it's all just sort of like, when it's done, right? As far as how many more iterations until 1.0, so I've talked about this with Evan, the creator of Elm, and basically what he said is sort of like, 1.0 should be a really boring release, and really you want to cut 1.0 when you're saying like we haven't changed anything in a while, so why don't we just announce that we're stable now? But Elm is still changing. It's still sort of like evolving, and the last 3 releases have removed features on purpose to try and make it even simpler. And as long as that's sort of happening on a regular basis, it seems like it would be like a little bit disingenuous to say, oh, we're at 1.0, you can trust everything now. It should be more of a like, okay, things have been stable for a while, now let's call it 1.0.
Okay, so fast answers. What about backend compatibility? Can I use Elm to build Node, e.g. Express app?
Yeah, not yet. So I mean, in as much as Elm can interoperate with JavaScript, like if you want, you could run Elm on the server and just only put business logic in Elm, but then like do interop for like database and HTTP and like everything. But that sounds like a lot more work than it's worth, to be honest. So yeah, basic answer is not yet.
And with that answer, thank you very much. Really appreciate it.